Hello students, how are you all? I hope that you all are good. And in a last session, we are discussed about units and measurements topic, class number 01. And in that session, we are discussed about physical quantities. And what is physical quantities? What are the types of physical quantities? Okay, and what is conversion factor? What is the use of conversion factor? And all these things that we are discussed in a previous lecture. And this lecture is units and measurements class 02. In this session that we are going to discuss about dimensions of a physical quantities. So what is the meaning of dimensions of a physical quantities? Okay, what is the meaning of dimensions? How can we write the dimensional formulas for given physical quantities? What are the symbols of fundamental physical quantities to represent like a dimensions? Okay, plus how can we write the dimensional formulas for derived physical quantities? And all these things that we are going to discuss in this session. And my name is Rakesh Kanganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. And what is the session today? Units and measurements, class number 02. Okay. So today's topic is what? Dimensions of a physical quantities. Dimensions of a physical quantities. So what is the meaning of dimensions of a physical quantities? That means the dimensions of a physical quantities are the powers to which fundamental physical quantities are must be raised to represent that physical quantity. So what is the meaning of dimensions of a physical quantities? So the dimensions of a physical quantities are the powers. Dimensions means what? Simply dimensions means powers. Dimension means powers. To which, for which we have to give the powers? We have to give the powers to fundamental physical quantities. How many fundamental physical quantities are there? We have 7 fundamental physical quantities are there. We have to give the powers to fundamental physical quantities, and r must be raised to represent the physical quantity. So whatever the physical quantity we require, if we give the powers to these fundamental physical quantities, the required physical quantity is given by them. That means fundamental physical quantities. Okay, right. Dimensions means simply powers. Okay, right. So dimensional formula always placed in this braces. Okay, we have to place dimensional formula always in this braces. Okay, and the symbols of fundamental physical quantities are the symbols of fundamental physical quantities are fundamental physical quantities. Here I am taking the this side I am taking symbol. Okay, fundamental physical quantity and their symbol. First one, I am taking mass. I am taking what? Mass. So the dimensional symbol of mass is capital M. Okay. So second one, length. Length. So for length we have to take capital L. Third one, time. For time we have to take capital T as a dimensional symbol. Okay. Fourth one, temperature. For temperature we have to use capital K or theta. K or theta. Both are dimensional symbols for temperature. Fifth one, electric current. So electric current, the dimensional symbol for electric current is capital I or A, your wish, I or A. So in these two we can use one as a symbol for electric current. And the sixth one, luminous intensity. So the dimensional symbol for luminous intensity is candela, C. We can represent with a C. And the last one, sixth one, and the seventh one. Seventh one is what? Amount of substance. Amount of substance. So the symbol for amount of substance is mole. M-O-L. So that is the symbol for dimensional formula of amount of substance. Is it clear? So simply dimensions means powers to which fundamental physical quantities. If we give powers to fundamental physical quantities, what they represent, whatever the physical quantity we require, they are given to us. Okay. So the fundamental physical quantities. What are the fundamental physical quantities? Mass, length, time, temperature, electric current, luminous intensity, and the amount of substance. What is the dimensional analysis symbol for mass? Capital M. And always we have to place a dimensional symbols in these braces. Okay, right. Mass, capital M; length, capital L; time, capital T; temperature, K or theta; electric current, I or A. Okay, luminous intensity, C; amount of substance, mole. Is it clear? These are the symbols for fundamental physical quantities to write in a dimensional formulas. Is it clear? Pause the video and write the notes or take the screenshot. 3, 2, 1, go. Right. Let us see some dimensional formulas of physical quantities. First one, area. What is area? Simply area can be written as length into breadth. Length into breadth. Okay. So what is length? Length can be measured in meters into breadth is also measured in meters. Meter is nothing but what? Length. What is the dimensional symbol for length? Capital L. Are you getting? What is the dimensional symbol for meter? Length. L into L, L square. Any mass term is there? Any mass term present here? No mass term will be present. So mass power how much? 0. Any time term is there? No time term will be present. Then time power 0. So this is a dimensional formula of area. Are you getting? Right. Second one, volume. What is the formula for volume? Length into breadth into height. Length into breadth into height. Length is nothing but what? Length. That is a dimensional formula for length is L. Breadth is nothing but what? Breadth is also nothing but length. See, this is the breadth of the board. We are measured in 2 meters, 3 meters like that. Meter is nothing but what? Length. So dimensional formula for again length is how much? L. Height. Height is also measured in meters. That means it is also length. L into L into L. What is that? L cube. Any mass term present? No mass term present. There is no kgs, no mass is present. So m power 0. And any time term present? No. So this is the dimensional formula for what? Volume. Are you getting? So the third formula. The third one is density. What is density? Density is nothing but what? Mass by volume. Mass per unit volume is called what? Density. Mass. What is the dimensional symbol for mass? Capital M divided by volume. What is the dimensional formula for volume? L cube. M power 0 means 1. T power 0 means 1. Remaining what? L cube. Okay. So M power 1. M power nothing is there means M power 1. If L cube comes to numerator, it becomes L to the power of minus 3. And any time term is there? No time term. Then T power 0. So this is the formula for density. Are you getting? Any doubt? Right. Fourth one, velocity. What is velocity? Displacement by time. Velocity means what? displacement by time. Displacement can be measured in length, 2 meters, 3 meters, displacement 4 meters. That means displacement is nothing but what? Length. So the dimensional formula for length is what? L divided by time. Time is nothing but what? T. That is equals to any mass term present here? No mass term. So mass power 0. Length is there, L. L power is how much? 1. If T comes to numerator, it becomes T power minus 1. So this is the dimensional formula for velocity. Are you getting? Any doubt? Right. Fifth one, acceleration. What is acceleration? The rate of change of velocity is called a acceleration. That means velocity divided by time. Velocity divided by time is called what? Acceleration. Are you able to see the board? No. Right. Are you getting this? Acceleration means what? Velocity divided by time. Okay. So I'm just writing the acceleration as A is equals to velocity into 1 by time. Can I write like this? Velocity into 1, velocity divided by time. What is velocity? Displacement by time. Displacement by time into 1 by time. Displacement measures in length divided by time. The dimensional formula of time is what? T. One more time is there, T into T square, so which is equals to any mass term present here? No mass term present, m power 0. L is there, L power how much? 1. If T comes to numerator, it becomes T power minus 2. So this is what the dimensional formula for acceleration. So the sixth one is momentum. So momentum can be represented by P. Okay, na? So momentum is equals to mass into velocity. Momentum is equals to what? Mass into velocity is called a momentum. So mass. What is the dimensional formula for mass? Capital M. Velocity. Velocity is nothing but what? Displacement by time. Are you getting? Right. So m power how much? 1. L power 1. T comes to numerator, it power tends to negative. Are you getting? I'm just write the direct formula. Okay, right. So seventh one, force. I'm writing for force. Force is nothing but what? Mass into acceleration. Mass into acceleration. Mass. What is the dimensional formula for mass? Capital M into acceleration. Acceleration is nothing but what? Velocity by time. Velocity is nothing but what? Displacement by time, L by T. Already one more time term is there, L by T into T square. So acceleration means what? L by T square. Are you getting? Right. Okay. So m power 1, L power 1, T power minus 2. Okay. Any doubt? No doubt. Okay. Ninth one, torque. What is torque? Torque is equals to force into displacement. Force into displacement. Force. What is the meaning of force? Mass into, are you able to see the board? Right. So force means mass into acceleration. Acceleration formula is what? L by T square. F is equals to ma into displacement L. Are you getting? Okay. So now torque is equals to what? Torque is equals to m power 1 L into L square divided by T square. If T comes to numerator, it becomes T power minus 2. Are you getting? Are you understand how to write the dimensional formulas? I hope that you are understand. 10th one. The 10th one is a moment of inertia. Moment of inertia. So the moment of inertia can be represented by capital I, that is equals to mr square. I is equals to what? Mr square. So where m tends to mass and r tends to radius or distance, whatever it is. Okay. So write the dimensional formula for moment of inertia. 3, 2, 1. Pause the video and try this. Try this one. 3, 2, 1. Go. So moment of inertia dimensional formula. I is equals to mass capital M. Distance. R means what? Distance. Distance is nothing but what? Length. L square. Any time term is there? No. T power 0. That's it. Any problem? No problem. Pause the video or take the screenshot your convenient. 3, 2, 1. Go. See the next one. Note. The physical quantities having same units. The physical quantities having same units, then their dimensional formula is also same. And the dimensional formula is also same. What is the note? The physical quantities having the same units, then the dimensional formula is also same. Right. So we are finished with 10 formulas and the 11th one. Right. So the 11th one is work. Work. So what is work? Work is nothing but what? Force into displacement. W is equals to F into S. Force into displacement. Okay. So what is force? Force is nothing but what? Mass into acceleration. Displacement means what? S. So mass. Dimensional formula for mass. Capital M. Acceleration. Acceleration is nothing but what? Velocity by time. L by T square into displacement L. So M power 1 L into L square. T power minus 2 comes to numerator, it becomes T power minus 2. T power 2 comes to numerator, it becomes T power minus 2. So 12th one, energy. So whatever it is, kinetic energy or potential energy. I am taking a kinetic energy. So what is kinetic energy? Kinetic energy is equals to half mv square. Okay, note. So what is the note? The constants, comma, trigonometric functions like a sine theta, cos theta, and so on, and log arithmetics has no dimensional formula. Constant does not have any dimensional formulas. So now what is kinetic energy? Kinetic energy is equals to half mv square. Constants has no dimensional formula. So it has no dimensional formula. Mass. Mass. What is the dimensional formula for mass? Capital M. V. V means velocity. Distance by time. And velocity has square term. Mass. Capital M. Velocity. Distance by time square. Right. So then kinetic energy is equals to, are you able to see the board? Okay. Kinetic energy is equals to what? M L square. L square divided by T square. M L square divided by T square. That is equals to, so see, M power how much? 1 L square. If T power 2 comes to numerator, it becomes T power minus 2. Have a look. So we got dimensional formulas of work and kinetic energy are same because the physical quantities having the same units, the units of work and kinetic energy or energy, both are same. So units are, SI units of work is joule, joules. So the SI units of kinetic energy is also what? Joules. So because their SI units are same, that's why the dimensional formula of work and kinetic energy is also same. Any doubt? Right. So 12th one, next 13th one. Okay, so the 13th one is potential energy. Potential energy is equals to mgh. M means mass, capital M. G means acceleration due to gravity, that means L by t square. H means height, length. H means height. Height is measured in terms of length, 2 meter, 3 meter, like that. So M, L into L, L square. If t power minus 2 comes to numerator, if t power 2 comes to numerator, it becomes t power minus 2. See, potential energy also got the same dimensional formula. M power 1 L square t power minus 2. Any doubts? Okay. 14th one. The 14th one is stress. Stress. Stress is nothing but what? Force acting per unit area. Force by area. Force. What is force? Mass into acceleration divided by area. So mass, dimensional analysis symbol, capital M. Acceleration, L by t square. Area, L square. So L get cancelled out. Finally we got M power 1. If L comes to numerator, L power minus 1. T square comes to numerator, T power minus 2. M power 1, L power minus 1, T power minus 2. This is the dimensional formula for stress. Okay, right. So the 15th one. The 15th one is strain. What is that? Strain. Strain is nothing but change in length to its original length. Delta L by L. What is the dimensional formula for L? Length, capital L. What is the dimensional formula for L? Again, capital L. So L get cancelled out and we got M power 0, L power 0 and T power 0. That means strain has a no dimensional formula. Next, 16th one. Pressure. Pressure can be denoted by capital P. So pressure P is equals to again force by area. Force upon area. So P is equals to, what is force? Force is nothing but mass into acceleration. Area is nothing but area only. So mass can be represented by capital M into acceleration. Velocity divided by time. Velocity is nothing but what? Displacement by time. One more time term is there. So for acceleration we get L by t square. And what is area? L square, meter into meter. Okay. Are you getting? So 1L get cancelled out. So M power 1. If L comes to numerator, it becomes L power minus 1. And a t square comes to numerator, it becomes t power minus 2. So this is the dimensional formula of pressure. Are you getting? Right. Pause the video and write the notes or take the screenshot. 3, 2, 1, go. So the 17th one. Aerial velocity. Aerial velocity. So what is aerial velocity? Area by time. Actually the formula for aerial velocity is area covered divided by time. Area by time. What is the dimensional formula for area? L square. What is the dimension for time? Capital T. Any mass term is there? No. M power 0, L square, T power minus 1. If T comes to numerator, its power becomes minus 1. Are you getting? Right. 18th one. Angular momentum. Angular momentum. So angular momentum can be denoted by capital L. So angular momentum is equals to mvr sin theta. mvr sin theta. So the trigonometric function has no dimensional formula. So then angular momentum is equals to m is what? Mass. M is what? Mass. Capital M. V means what? V means velocity. Distance by time. R means what? Radius. That means it is also displacement. That means length. So M, L into L, L square. If T comes to numerator, it becomes T power minus 1. So this is the dimensional formula for angular momentum. Are you getting? Any doubt? Right. So the next one. Angular velocity. Angular velocity. It can be represented by omega. So angular velocity formula is perpendicular velocity divided by radius. V perpendicular upon radius. So which is equals to, what is velocity? Distance by time into 1 by r is there. R is nothing but what? Radius. Radius is nothing but what? Length. So L get cancel off. If t comes to numerator, it becomes t power minus 1. Any mass term is there? No. M power 0. Any length term is there? No. L power 0. Are you getting? Easy one. Concept is easy. Easy concept. Concept is difficult, sir. But you made the concept easy. Thank you. Okay. Right. Don't do overactions. Say the class. Okay. Right. So next one. Angular acceleration. Angular acceleration. So angular acceleration can be denoted by alpha. So alpha means the rate of change of angular velocity is called what? Angular acceleration. The rate of change of angular velocity is called angular acceleration. T power minus 1 divided by t for time. The dimensional symbol is what? Capital T. If t comes to numerator, already t power minus 1 is there. Again, if t comes to numerator, it becomes t power minus 1. T power minus 1, t power minus 1, t power minus 2. Are you getting? If it is went to numerator, it becomes t power minus 1. Bases are same. Powers will be added. Minus 1, minus 1, minus 2. So that is what? Angular acceleration. So 21. Frequency. What is frequency? Frequency is nothing but reciprocal of time. Reciprocal of time is called, or reciprocal of time period is called what? Frequency. So which is equals to, any mass term is there? No. M power 0. Time term is there. What is that? Only t. If t comes to numerator, it becomes t power minus 1. No length term. T power minus 1. Are you getting? Any doubt? Okay. 22nd. Angular frequency. Angular frequency. So angular frequency is equals to what? 2 pi f. Angular frequency is equals to what? 2 pi f. This is the formula for angular frequency mark. So 2 pi is constant. It has no dimensional formula. And f means what? Frequency. What is the dimensional formula for frequency? Again, m power 0, L power 0, t power minus 1. Are you getting? Right, very good. So 23. Temperature gradient. Temperature gradient. So the formula for temperature gradient is change in temperature to length. Change in temperature to length. So temperature. So the dimensional symbol for temperature is what? K. Y. Length. Capital L. So m power 0, L power, L comes to numerator, its power becomes minus 1, and K power 1, there is no time term. T power 0. Are you getting? Any doubts? Easy concept or tough concept? This is one of the easy concept. Are you getting? Okay, very good. Okay, next 24. Charge. What is charge? So charge can be represented by capital Q. Q is equals to IT. Q is equals to what? I into T. So I means what? Electric current. I means what? Electric current. And T means what? Time. Okay. So now the dimensional formula. What is the electric current's dimensional symbol? What is that? Capital I. T. T means what? Time. So I power 1, T power 1, and M power 0, L power 0. If you place M power 0, L power 0, if you place otherwise, leave it. Okay, I power 1, T power 1 is the dimensional formula of charge. Are you getting? Right. 25th one. So the 25th one is what? Potential. What is that? Potential. So potential capital V is equals to W by Q. Potential capital V is equals to W by Q. W means work. Q means charge. So W, work done. What is work done? Force into displacement divided by Q. Force, F is equals to mass into acceleration, L, T power minus 2, acceleration. L by T square, right? Displacement L, Q, charge, I power 1, T power 1. So which is equals to M power 1, L into L square. If I power 1 comes to numerator, it becomes I power minus 1. T power 1 comes to numerator, T power minus 1. T power minus 2, T power minus 1, T power minus 3. So this is the dimensional formula of an potential. Okay, are you getting any doubts? Right. So pause the video and write the notes. 3, 2, 1, go. Okay, right. I hope that you understood how to write the dimensional formulas for given physical quantities. If you know the formula of given physical quantity, then you can easily write the dimensional formula of whatever the physical quantity they are given, you can write easily. So the next concept is dimensions of dimensions dimensional dimensional formula of some constants, dimensional formulas of some constants. Okay, first one, refractive index. First one is what? Refractive index. So refractive index can be represented by mu, this letter. Okay, mu. So that is equals to C by V. Mu is equals to what? C by V. C means speed of light in space, free space. V means what? Speed of light in medium. Speed of light in free space to speed of light in medium. The ratio of these two is called what? Refractive index. Are you getting? Right. So mu. Speed. Speed means what? Speed is nothing but velocity. Distance by time. V. V means velocity. Again, distance by time. TT cancel out. LL cancel out. So any mass term is there? No. Any length term is there? All length terms are cancelled out. L power 0. Any time term is there? No. So m power 0, L power 0, P power 0. Second one, gravitational constant. What is that? Gravitational constant. Okay. So what is the gravitational force formula? Capital F is equals to capital G m1 m2 by r square. So where m1 m2 tends to mass, r tends to distance, F tends to force. What we have to find? Capital G. So capital G is equals to capital F into, if R comes to this side, R square divided by M1 M2. Are you getting? Capital G is equals to F into R square divided by M1 M2. Capital F, force. F is equals to what? M A L T power minus 2. R square. R is nothing but what? Distance, L square. Mass, M into M. M into M. Are you getting? So mm get cancelled out. So if m comes to numerator, it becomes m power minus 1. Okay. So L square into L cube, T power minus 2. So this is what? The dimensional formula of gravitational constant. So the third one, Planck's constant. Planck's constant. So E is equals to HF. E is equals to HF. Where E is called what? Energy. F means frequency. And H is what? Planck's constant. Okay. So H is equals to, we can write E by F. H is equals to what? E by F. What is E? Energy. So the energy, whatever it is, heat energy or whatever it is, just you write the formula for kinetic energy or potential energy. It is equals to the formula of energy. Either if it is heat energy, you can write formula, dimensional formula of kinetic energy. It is also becomes what? It is also equals to an energy formula. Either it is kinetic energy, potential energy, heat energy. For all these energies, dimensional formula is same. So what is the dimensional formula for energy? M L square T power minus 2. If you take kinetic energy, half mv square. Okay, half cancel out. M means mass, V L by T whole square. So M L square T power minus 2. This is for kinetic energy, potential energy, heat energy represented by capital Q. For all these, you can write ml square t power minus 2. This is the dimensional formula of energy. Okay, divided by frequency. What is frequency? What is frequency? The reciprocal of time, f1 by t. Okay, so the dimensional formula of t is what? T. If it is comes to this, it becomes t power minus 1. If it is comes to numerator, it becomes t power minus 1. So here t power minus 2 is there. Here t power minus 1 is there. Both are get cancelled out, and here remaining term is what? T power minus 1. So m power 1 L square t power minus 1. Are you getting? So this is the dimensional formula of Planck's constant. Okay, right. I hope that you are understand how to write the dimensional formulas for given constants. Is it clear? Any doubts? Pause the video and write the notes. 3, 2, 1, go. Okay, right. So let us see some previous year examination questions we got from this concept. Okay, right. So these are the previous year problems that we are got in our previous examination. So first one is what? AIMS 2016, and second one is All India Pre-Medical Examination Test 2007, and this is AIMS 2016 problem. Let's see solve the problems. Right. So pause the video and try these questions. Okay. 3, 2, 1, go. I hope that you are solved the answers of these questions. The first one is what? Magnetic moment. So the formula for magnetic moment is NIA. Magnetic moment is equals to what? NIA. Where N tends to number of turns. In second year, you will get a magnetic moment. So I tends to current. I tends to what? Electric current. A tends to area. A tends to what? Area. Okay. So N is a constant value. Constant does not having any dimensional formula. So I means what? Electric current. And the area means what? L square. I into L square. I into L square is there? No. So I told you that whenever I wrote the symbols of fundamental physical quantities, there I can write a electric current symbol I or A, ampere or A. I just write that like this. So now I is nothing but what? Capital A into L square. So I, A, both are the symbols for what? An electric current. So what is the option? A into L square. So option 2 is correct. Are you getting? Okay. Second one, electric resistance. So second one is what? Electric resistance. So according to Ohm's law, we can write V is equals to IR, where R is nothing but what? Electric resistance. So R is equals to V by I. So V means what? Potential difference. Potential difference, and I tends to an electric current. Okay, so potential difference. Potential difference means what? Already we have discussed. W by Q. I means what? An electric current. W means work done. W is equals to F into S. Force into displacement divided by Q into I. Force. Force is nothing but what? Mass into acceleration into S by Q into I. So mass. Capital M. Acceleration. L by T square into S, displacement. Displacement is nothing but L divided by charge. Q is equals to I into T. I means A, an electric current, into T, time. I means what? Electric current. Are you getting? Mass, capital M, acceleration, L by T square, displacement L. Q is equals to what? IT. Q is equals to IT. Charge. I means electric current, capital A. T means time. Into and electric current, I is equals to what? A. So then, so M into M power 1, L into L square. So here T square is there, here T is there. T square into T power cube. If T power cube comes to numerator, T power minus 3. Denominator a square is there. If a square comes to numerator, it becomes a power minus 2. And this is the answer. So m power 1 L square t power minus 3 a power minus 2. Option 2 is the correct answer. Is it clear? Write the notes. Pause the video and write the notes. 3, 2, 1, go. Alright. So the last question, dimensional formula of magnetic field. So third one. So we have the formula, force on a charge when it is kept in a magnetic field is given by F is equals to Q into V bar cross B bar. So B is nothing but what? Magnetic field. B is nothing but what? Magnetic field. So from this, B is equals to, we can write F by Q into V, where F tends to force, Q tends to charge, V tends to velocity. V tends to what? Velocity. Now it is easy to write dimensional formula. Force F is equals to M A, acceleration L T power minus 2. Are you getting? Q, charge Q is equals to I into T, velocity, displacement by time, Tt get cancelled out, Ll get cancelled out. So m power 1 t power minus 2, if a comes to numerator it becomes a power minus 1. So m power 1 t power minus 2 a power minus 1. All L's are get cancelled out in this equation. So we can write L power 0. There is no L, but if we want to put L power 0 to get the answer. What is that? Option 2 is the answer. M power 1 t power minus 2 a power minus 1 L power 0. Is it clear? Any doubts? What is Q? Charge. Q is equals to I into T. So Q, I can be represented by A. T means T. At. Q is equals to at. Is it clear? Any difficulty is there? Right, no difficulty is there. Okay. So also we have the formula for permittivity, permeability. So all these things. Take your textbook. In your textbook, you will get more formulas of dimensional analysis. On dimensional analysis, they will give the physical quantities and their formula. After that, they give the dimensional formulas of those things. Okay. So take your textbook and practice. Okay, take your textbook and practice. Don't skip. Even small concept is also very important. We don't know, from any corner they are asked any question, so don't left any concept and any video. So I hope that you are clear about this concept and you get the capacity to write the dimensional formulas of any physical quantity. Okay, so this is the end of the today's session. We will meet on next lecture. Until then, stay tuned. Rakesh Kanganti signing off. Jai Hind.